Before we can know what happens when our spoonful of neutron star comes to Earth, let's think about what's in our spoon. Imagine a lemon in tablespoon. In this case, it's a super dense collection of neutrons. A neutron star is the remnant of a massive star, bigger than 10 suns, that has run out of fuel, collapsed, exploded, and collapsed some more. Its protons and electrons have fused together to create neutrons under the pressure of the collapse. The only thing keeping the neutrons from collapsing further is neutron degeneracy pressure, which prevents two neutrons from being in the same place at the same time. The star loses a lot of mass in the process and winds up only about 1.5 times the sun's mass. But all that matter has been compressed to an object about 16 kilometers across. A normal star of that mass would be more than 1.6 million kilometers across. A tablespoon of the sun, depending on where you scoop, would weigh about 2 kilograms, equals to the weight of an old laptop. A tablespoon of neutron star weighs more than 900 billion kilograms, which equals to the weight of Mount Everest. So while you could lift a spoonful of sun, you can't lift a spoonful of neutron star. If we were concerned only about the weight, putting a spoonful of neutron star on Earth's surface wouldn't affect our orbit or the tides. It's like adding another mountain. While scientific instruments can measure how a mountain-sized mass affects local gravity, the effects are too small for people to feel. So unless you stood right next to the spoon, you wouldn't notice. However, we're not just worried about the mass in the spoon. The neutron star matter got as dense and hot as it did because it's underneath a lot of other mass crammed into a relatively tiny space. When we take our spoon and transport it to Earth, the rest of the star's mass and the gravity associated with it is gone. Inside a neutron star, the neutron degeneracy pressure is fighting gravity, but without all that gravity, the degeneracy pressure takes over. Imagine you have a can of soda and it's all shaken up. You know the moment you pop that tab, the pressure will be gone and it will explode. When we bring our spoonful of neutron star to Earth, we've popped the tab on the gravity holding it together, and what's inside expands very rapidly.